Hello everyone, welcome to Talanta 50-day NEET 2023 special crash course series on day 23rd. So, in today's lecture, we are going to discuss some MCQs regarding the class 12 inorganic chemistry, the chapter D and F block elements. So, in day 24th, you also get some more new sort of MCQs on these D and F block elements. So let's begin with today's first question. Find the correct match. In column 1, some catalysts are given. These are very important catalysts mentioned in different chapters of NCERT, and these are their applications. You have to match, matrix match sort of question are very common since last 2 years in the NEET. If you have gone through the previous year questions properly, you can find it out easily. So that's why on that note we have created this first question. So MnO2, it basically acts as catalyst during decomposition of KClO3. So one is matched with D. Next, vanadium pentoxide V2O5. It is basically used in manufacturing of sulfuric acid. So 2 is matched with C. Next, Ziegler-Natta catalyst. It is basically highly used in manufacturing of high density polyethylene and copper nickel alloys. It's making coins. That's why they are referred as also coinage metals. So option A is the correct answer. Next, we'll move to question 2. Which of the following will shift the equilibrium to right? So this is the reaction. Dichromate Cr2O7 2 minus is orange red colored. In aqueous condition, it's being converted to 2CrO4 2 minus plus H 2H plus. So which of the following will shift the equilibrium to the right? First option is addition of KOH. Well, when we add KOH into the solution, the OH minus from KOH will abstract the H plus present in the right hand side of the equation. And as H plus is consumed by OH minus, so in the right hand side, the amount of H plus will reduced. According to Las Atelier principle, the system will have an inherent tendency to increase the concentration of H plus. So that's why the reaction will move towards forward direction. So option A is the correct answer. We'll move to question 3. 1 mole of MnO4 2 minus in acidic medium disproportionate to. In acidic medium, this is a very common reaction, is mentioned in NCERT. So the reaction is like that: 3 MnO4 2 minus reacts with 4H plus to generate 2 MnO4 minus plus MnO2 plus 2H2O. So this is a disproportionation reaction happening over here. Manganese here is in +6 oxidation state. In MnO4 minus, it is in +7 oxidation state is increasing, and in MnO2 it is in +4. So option 1 mole of MnO4 2 minus in acidic medium disproportionate 2. So 3 moles produces 2 moles of MnO4 minus. Then 1 mole of MnO4 2 minus will produce 2/3 mole of MnO4 minus. And from 3 moles of MnO4 2 minus, we are getting 1 mole of MnO2. Then from 1 mole of MnO4 2 minus, we will get 1/3 mole of MnO2. So option A is the correct answer. Next, we'll move to question 4. The manganate and permanganate ions are tetrahedral due to. Manganate ion, this structure, formula is MnO4 2 minus, and permanganate is MnO4 minus. So The first option is the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. The structure will be like that: Mn double bond O, double bond O, O minus, O minus, and another one will be this. The first option is the pi bonding involves overlap of p orbitals of oxygen with d orbitals of manganese. Yes, that's correct. Lone pair and p electrons are involved in overlapping with the vacant d orbital of manganese. This is correct. There is no pi bonding. Of course, is quite loud and clear from the structures. These pi bondings are present over here. Next option C is the pi bonding involves overlap of p orbitals of oxygen with p orbitals of manganese. Not p orbital of oxygen with d orbitals of manganese. And option D is the pi bonding involves overlap of d orbitals of oxygen with d orbitals of manganese. No d orbitals are present in oxygen. So option A is the correct answer. We'll move to question 5. Which one of the following ions exhibit DD transition and paramagnetism as well? So DD transition and paramagnetism, both will be shown by, CrO4 2 minus, CrO4, at first we have to see CrO4 2 minus. It's here chromium is in +6 oxidation state. So this is 3D0 system. No d electron is present, so DD transition is not possible. In Cr2O7 2 minus, again chromium is in +6 oxidation state. So it is another 3D0 system. No DD transition is possible. MnO4 minus, Mn is in +7 oxidation state. Another 3D0, no DD transition. MnO4 2 minus, it's Mn +6 state, manganese is remaining. So this is basically a 3D1 system. So here DD transition is available, and due to presence of these 3D1, one unpaired electron, it is paramagnetic in nature. So option D is the correct answer. We'll move to question 6. The reason, question 6, the reason for the greater range of oxidation states in actinoids is attributed to, first option is the radioactive nature of actinoids. Nope. Second option is actinoid contraction. The third option is 5F, 6D and 7S levels having comparable energies, and option 4 is 4F and 5D levels being close in energies. Actinoids, so 5F, 6D and 7S. Lanthanoid is 4F but is 5F in case of actinoids. So option C is the correct answer. Next, question 7. Which one of the following statements is correct when SO2 is passed through acidified K2Cr2O7 solution? So here basically green chromium sulfate is formed here, and the oxidation state changes from +6 to +3. So sulfur dioxide here acts as oxidizing agent here, and sulfur dioxide is not reduced here. It is basically is sulfur dioxide is oxidized here. Sulfur dioxide here is acting as reducing agent, and the final product will get green Cr2SO4 whole 3. So option C is the correct answer. Next question 8. A magnetic moment of 1.73 Bohr magneton will be shown by one among the followings. So 1 point something means the value of n will be 1. Number of unpaired electrons will be 1. So in CuNH3 whole for 2 plus, the copper is in +2 state. You have to it is in nickel plus 2. Here titanium is a plus 4 oxidation state. Cobalt is plus 6. So you have to find out where uh, number of unpaired electrons is 1. So here copper plus 2. Copper plus 2 means 3d9 system. So 3d9 system means number of unpaired electrons here obviously 1. So option A is the correct answer. Next, question 9. In extraction of copper from its sulfide ore, the metal is finally obtained by the reduction of cuprous oxide with first option copper 1 sulfide, second sulfur dioxide, iron sulfide, and fourth option is carbon monoxide. The reaction is actually Cu2s reacts with 2Cu2O to produce 6Cu along with SO2. This is the reaction. So option A is the correct answer. Next, question 10. Acidified K2Cr2O7 solution turns green when Na2SO3 when Na2SO3 is added to it. This is due to the formation of course, turns green. Green is color is formed due to the formation of Cr2SO4 whole 3, and copper is in plus 3 state, generally show green color. So B option is correct. Question 11. Out of TiF6 2 minus, COF6 3 minus, U2Cl2 and NiCl4, the colorless species are. So TiF6 2 minus, here titanium is in plus 4 oxidation state. Plus 4 titanium means the 3D0 system. So it will be colorless. And Cu2Cl2 copper is in plus 1 oxidation state. That is, it is a 3D10 system. So no DD transition is possible. This is also colorless. COF6 3 minus, no, this is colored. NiCl4 2 plus, this not has D0 or D10 electronic configuration. So NiCl4 2 minus is colored as well. So option C is the correct answer. We'll move to question 12. The main reason for larger number of oxidation states exhibited by the actinides than the corresponding lanthanides is. First option, more energy difference between 5f and 6d orbitals than between 4f and 5d. No. Next, lesser energy difference between 5f and 6d orbitals than between 4f and 5d. Yes, this is the correct answer, because when the energy difference is lesser, then exchange of electrons is possible in many a way. So we will get several number of stable oxidation states. So option B is the correct answer. Next, question 13. Among the following series of transition metal ions, the one where all metal ions have 3d2 electronic configuration is. It's a very easy question. You have to write down the electronic configuration and you can find it out very easily. So I'm not explaining it. It will be option D is the correct answer. Next, question 14. The temperature of blast furnace to produce iron from its ore Fe2O3 varies from 500 degrees Celsius at the top of the furnace to about 1900 degrees Celsius at the bottom of the furnace. The reason between the ore Fe2O3 and CO at the lowest temperature, the reaction between ore of Fe2O3 and CO at the lowest temperature at around 500 degrees Celsius is. Around 500 degrees Celsius, actually Fe2O3 is reduced by CO to form Fe and CO2. So option C is the correct answer. Next, question 15. ZNO, when heated with BaO at 1100 degrees Celsius, gives the compounds. Identify the compound. So this is an important reaction and short of informative. You have to know it properly, otherwise you can't answer. At 1100 degrees Celsius, it basically forms this compound. So barium zincate. So option A is the correct answer. So that's all for today. Thanks for watching. Thanks for sharing our videos. Thanks for sharing good words about Talanta. If you are new in this channel today, don't forget to subscribe our channel. Hope you all people who have seen the video have again some extra cartage scale about this DNA block MCQs. So please press the like button and share this video among your friends to develop together. Thanks once more.